All right, how are we going to graph trig transformations? How are we going to take these graphs and move them left, right, up, down, and all over the place? Well, if we think about what a sine function looks like. Now, we can take this sine function and we can squeeze it down and shrink it down. We can take it and make it bigger along the y and the x-axis. We can take this graph and slide it left. We can slide it right. We can move it up. We can move it down. Well, that's what we're going to look at today, is how are we going to take a sine function and change the period, which will make it become shorter or longer. How are we going to change the amplitude, which is going to make it taller or shorter, and how we're going to slide it left and right. We're going to look at all of those today. Now, let's get started with it. So, what are we going to look at first? Well, how do we graph a trig function? What does this big, all these letters and all this mean? Well, it means we have an amplitude, we have a period, we have a phase shift, we have a vertical shift. Well, our amplitude is the A out front. That tells us that when we have a thing called a midline, where our function will oscillate up and down from, that A tells us how far up and how far down we're going to oscillate up and down from that midline. Now, what is this funky looking W? That's omega. And omega talks about our period. That talks about how long our graph is going to go. Now remember, it comes from the unit circle. So our period talks about how long we start and we travel one full loop around the circle. That is related to our period. Now, our phase shift, everyone's favorite, moving it left and right. Now, our phase shift talks about this letter, and it uses our omega letter. It uses both of them to talk about our phase shift. Now, the vertical shift is the number outside. So that number outside here, which is C, that talks about our vertical shift. That's going to take this midline and everything we have here, if we grouped it together, it would take it and move it up and down along the y-axis. So that's what's happening with all these letters and everything going in there. Now, I know you may be thinking, well, does this only work for sine? No. We could write cosine in there. We could write tangent. We could write cotangent. We could write secant. We could write cosecant. And those functions are still going to have these letters in it, and it's going to change the function the same way. Now, the way they look will be a little different, depending on whether it's a sine, cosine, and such. So, let's look and see what exactly we have next. Now, all we're going to do is take our equation and just find the things inside of it. So if we have the equation here, y equals 5 sine 3 theta minus 5. Now, what's inside each one of these functions? What does that 5 mean? Remember that 5 goes with our amplitude. So our amplitude is 5. Let me erase that and make that 5. Scratch that out and make that 5 look a lot better. Now, what about our period? We have a great formula up above. Now, that omega, that's what's going to be in front of our theta sign. That is omega. Now, it says up above to find our period, we're going to take 2 pi and divide it by that omega. So, all we have to do really is draw a line above it and write 2 pi, right? Because isn't that 2 pi over omega? Well, 2 pi over 3, we can't simplify that at all, so we just leave that exactly like we see it as 2 pi divided by 3. Now, what is our phase shift? Remember, our phase shift is going to take 2 numbers. It's going to take the -5 and the omega. Now, our phase shift, what it does is it says, okay, we need to put a negative out front because we have to change the sign. Now, if we put a negative out front, that's the same thing if we make a negative of a -5. It changes the sign. And we need to divide that by our omega here, our 3. So negative times a negative gives us a +5 over 3. So our phase shift is 5/3. Now, let's look at a second problem and make sure that we understand this fully. So, give yourself a second and work this one out and see how you do on it. Well, what do we see here? Oh, wait. What's the number here in front of sine? Well, remember, if there's not a number there, we always use a 1 in math that represents that. So we have a 1 for our amplitude. Well, what's our period going to be? Remember, we take our omega here, and we have to divide it by is 2 pi over omega. So our period is going to equal 3 pi divided by 2 over 2 pi. Now, when we work this out, we have a division and a division problem. So sometimes what I like to do is write as 2 pi divided by 3 pi over 2. Because when we see it horizontally, sometimes we remember we've got to copy, change, and flip our second fraction. So when we do this, we copy our first 2 pi, change to multiplication, flip our second one, so our 2 will go on top, our 3 pi goes on the bottom, that's 2 over 1, and remember when we multiply, we go straight across, so we're going to get 2 pi times 2, which gives us 4 pi, 1 times 3 pi is 3 pi, and our pi over pi is going to cancel out, so all we're going to be left with is 4/3. Now, what do we start with? That was our period, which is going to be 4/3. So let's go up to the top and label that in. So our period is 4/3. Now, what's our phase shift going to be? Well, let's go ahead and plug in our numbers. Our phase shift is going to be negative phi over omega. Our phi and our omega. So that's going to be our negatives out front of a +1 over omega, which is 3 pi over 2. So copy, change, flip. So we have -1 times 2 over 3 pi. So it becomes -2 over 3 pi. And remember, that's going to be our phase shift is going to be -2 over 3 pi. So up here we'd have -2 over 3 pi. Great job looking through this. Now, let's look at exactly what do we do when we graph here. What's going on with our functions? How is this going to look on a graph? Well, to make it nice and easy, I like to use a little chart that I came up with, which plugging in our information makes it really, really simple. Now, taking our same formulas from before that we have up here that I'll highlight as I go through. Now, when we solve this out for our period, the number here in front of theta was 1, so our period is 2 pi divided by 1, which is 2 pi. And if you noticed, in my table, I labeled my 2 pi's all the way down here. Now, we have to look at our phase shift. Our phase shift says we have to take negative of negative pi over 2 divided by the number in front of theta, which was 1. So that's just going to give us a positive pi over 2, which I've added here. Now, when we graph, we have 5 points. We have a starting point and 4 points beyond it. And so that means we will end with 1 period here. So, looking through it, that is why we have a 0, 1/4, 1/2, 3/4, and 4 over 4 is the same thing as 1 because we have 1, 2, 3, 4 notches after our starting point. So if we start at 0, we have 1/4, 2/4, 3/4, and 4/4 beyond it. So filling out our table will give us our points down here. Well, if we look at this, if we take 2 times 0, we're going to get 0 plus pi over 2 is just going to give us pi over 2. So that's going to be our first spot. Now, 2 pi times 1/4 is going to give me 2 pi over 4 plus, well, pi over 2, we don't have a common denominator. If we multiply the top and the bottom by 2, we'll get 2 pi over 4, and 2 pi plus 2 pi gives me 4 pi over 4, which just gives me pi. Now, going through the next line, 2 pi times 1/2 gives me 2 pi over 2 plus pi over 2 will give me 3 pi over 2. Going on my next line, 2 pi times 3/4 will give me 2 times 3 is 6 pi over 4. Well, we don't have common denominator, so again, multiply by 2 and 2, so I get 2 pi over 4, and 6 plus 2 gives me 8 pi over 4, which gives me 2 pi. Now, lastly, I have 2 pi times 4 over 4, which gives me 2 times 4, which is 8 pi over 4, plus 2 pi, or plus pi over 2, so multiply by 2 and 2, so I get 2 pi over 4, and I get 10 pi over 4, which is 5 pi over 2. Now, remembering back to our amplitude. Now, our amplitude was that number in front of our sine function. That is our amplitude. That tells me how high above and below the midline I'm going to go. Well, our midline didn't change here, so because there was no vertical shift. So our midline is still going to be here at the x-axis. So our amplitude is going to be up to and down to. So 1, 2, 1, 2 from that midline. Now, we just draw in our parent function of what we learned in our previous lesson about how to graph the sine function. So our sine function at pi over 2 is going to be on the midline. At pi, it'll be at the top amplitude. 3 pi over 2 will be on the midline. At 2 pi, it'll be down at the bottom amplitude. And at 5 pi over 2, we'll be back on the amplitude. And we'll draw in our sine function. So that gives us y equals 2 sine, parentheses, theta minus pi over 2.